Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli, the Computer Guy, and in today's class, we're going to be doing a project where we're going to be creating a motion-sensitive spy camera. So this is going to actually take video footage. So we are using our ArduCam. It will record an AVI file to our SD card on our SD shield that we have connected to an Arduino Uno, and we will be triggering this using a PIR motion sensor. So essentially what will happen is this motion sensor, when it detects motion, it will then trigger the function to have the ArduCam start recording video. It will then save the video to the SD card. You will then be able to take the SD card out of the Arduino, be able to put it into your computer and be able to read the AVI file or be able to view the AVI file. So this is the project that I'm going to be showing you today. So the warning for today is not actually a warning for the project that I'm going to be showing you. This is relatively easy. So we're going to be taking a sketch that is given to you as an example in the ArduCam library. All we're going to be doing is we're going to be adding a PIR sensor to that sketch. We're going to be creating a little if-else statement, and really there's not a lot to the project itself. If you've been following along with the ArduCam videos, if you've been following along with the other Arduino videos, what I will be showing you today is very easy. Where the warning comes in is if you plan to customize anything that I show you today. So one of the issues that you're going to be running into using an ArduCam with an Arduino is, do remember, an Arduino is simply a microcontroller. It is not actually a full-fledged computer. So a Raspberry Pi is a full-fledged computer that happens to be small and inexpensive. It has a normal x86 processor, it has normal RAM, it has normal storage. It's a computer, and so there's a lot of things that you get with a computer that you don't really think about, you take for granted, and then you go to dealing with a Arduino microcontroller and you realize how much you're taking for granted. So one of the issues that I ran into is, originally when I was creating this project, I was going to do a very nice log file. So in a previous Spycam video, so basically when we're just taking a JPEG, just taking a picture image, not only did I take a picture, but then I also created a little log file for that picture saying the day of the week, basically what time the picture was taken, the Unix timestamp, some other information. So the nice part there was, not only did you get the image file itself, but you got that nice little log file to go along with it. Well, I have to tell you, I've been working for the past day trying to get all of that to work with the Arduino, and for me, I basically just gave up. Again, remember, in life, many times you don't fail. At a certain point, you just go, wow, this is taking too many resources, and so I'm going to go on to the next project. So trying to actually use the ArduCam in order to create an AVI file and then be able to interact with other files, I was having a mess of a time dealing with. A lot of weird errors going on, not necessarily where it fails out and you go, oh, I know why it's failing out. Just kind of fails. You do one thing and it works. It's like you're that close. You're that close. You're like, okay, I've done all of this and it works. And then you do that final little step just to finish it off, just to make sure everything is perfect, and then it would fail out. I've dealt with numerous different ways of trying to get around things, the whole 9 yards, and what I have found, as for the naming convention of the AVI files that you're going to be creating for trying to create a log file on top of also saving the AVI file, the whole 9 yards ran into just a massive amount of issues. And so this is one of those things, I'll be honest with you, I may have a video in 6 months where I realized what the quirks with all of that are, but for me at this point, I want to move on to the next project. This was just supposed to be a pretty simple thing, and so that is just something to keep in mind. So basically what's going to happen today with this project is, when the PIR sensor is triggered, what's going to happen is we're simply going to be creating a random name. So we're simply going to be creating a random name, adding on the .avi, and that will be the file name for the video that's been created. We're not having a real time clock, timestamp. We're not actually going to be able to create a log file. We're not going to be able to do any of that additional stuff because, again, when I was messing with it for a long time, it just kept failing out in the weirdest ways. So that is just something to be keeping in mind if you're looking at this going, oh, okay, I'm going to take what Eli did, copy and paste, do a little bit of modification, and I'll have an awesome project. Just realize if you start modifying this code and you go again to create additional files, do other things, you might run into some quirky issues. So this is just a very, very, very simple motion activated video camera. Basically, when the motion is detected, it will take about a 15-second video clip. It'll save it to the SD card. You'll be able to pull that SD card out. You'll be able to put it into your computer, but you're not going to get a very good naming convention. You're not going to get timestamps or anything like that. So those are some things just to keep in mind with this particular project. So now that I've proven to you that I'm not nearly as smart as you think I am, why don't we go over to the workbench? I'll basically show you how this all gets put together. Then we'll go take a look at the code, and then we'll take a look at the AVI file outputs. So this is how the ArduCam project is assembled, and basically it looks like a lot of the other ArduCam projects that we've done. So we have the ArduCam, and the ArduCam is connected just with the default connections going to the data logging shield that we have connected to our Arduino Uno. Again, for the ArduCam, the CS pin for the ArduCam itself is going to be coming into CS pin 7. Again, when you're using ArduCams, you can actually have multiple ArduCams connected to the exact same Arduino. The CS pin, that's basically the data pin for storage. That says where basically the storage for the video will be going into the SD card. And so for this particular project, we're just leaving the default as pin 7. Beyond that, again, we're using our Arduino Uno. Then we're using this data logging shield. This is a modern standards compliant data logging shield. The important thing is that SCL and SDA actually go all the way up into the shield itself. If you use an older data logging shield, that may not happen. The important thing is when I talk about standards compliant is, remember, we're using SPI I2C for the communication with the SD card reader. And so if you use non-standard compliant modules, you may run into issues with the ArduCam trying to store to the SD card. So this is the module I use for other projects. And to be clear, this is a great module for other projects, but when I try to use it with the ArduCam, I get a FIFO length error, and basically when I went down to troubleshoot it, there's some hard-coded configuration in this particular module so that it simply will not work with the ArduCam. So again, whatever shield you're going to use or whatever module you're going to use, make sure it's fully compliant for the SPI or I2C. Again, I'm just using this normal little hit Lego shield, and this has been based off of the Adafruit version. So beyond that, basically, the only other thing we have on here is the PIR sensor, our standard PIR sensor for this. Again, we have the VCC going into our little breadboard here, so that splits out the 5 volt. So 5 volt goes to the ArduCam and 5 volt goes to the PIR. For the ground just connects down onto the ground on the shield. And then for the actual sensor value, the PIR reading, that will be connected to digital pin 2 on the shield. And so this is all we have for how this particular project gets built. So with that, let's go over and take a look at the code. So here's the code for this particular project. Basically with this, I have simply modified the ArduCam Mini Video 2 SD example. So if you want to start from the beginning and then add your own particular sensors or whatnot, you can do that. So the first thing we're going to include is the stdint library. Then we're going to do the wire library, the ArduCam library, the SPI library, and the SD library. Beyond that, we're then going to have the memory saver. This is the configuration file. So make sure to go into memory saver, make sure that the correct module and the correct ArduCam have been basically de-commented in or uncommented in that particular configuration file. I have shown you that before. Then we're going to go down under ETCG notes here. Basically, we are going to do the configurations for the PIR sensor, that passive infrared sensor. We're going to define the PIR pin as digital pin number 2. Then we're going to create a variable int, so for basically for the reading, and that is going to be the PIR reading. So this is what we're going to be using to test for the if-else statements for whether or not to trigger a video to actually be captured. We're going to scroll down. There's a whole bunch of different things that are defined here. Be very careful if you modify any of these. Again, they have been commented by the ArduCam folks, but ArduCam can be a little quirky. To call it a little quirky is being kind of polite here. So they have things like the frames per second, a whole bunch of other stuff. One of the things you might want to tweak here is the total frames. So this is basically how many pictures in that video are going to be taken. The default is 200, and so I've left it at the default so there aren't any quirks when we do this particular project. We're going to go down here. Again, remember the SDCS pin. So again, when you're using something like a data logging shield, you may have to see what pin is used for the SD card for that shield. The default is 10, so we have plugged 10 in here. For the ArduCam adapter and their shields, their default is 9. So this is something that may have to be modified here, dependent upon your particular shield or your particular module. You're going to go through and you're just going to see a whole bunch of configurations that I would highly recommend you don't screw with unless you know exactly what you're doing. We're going to come down here. This is the static void. So what this is this is the actual function that we're going to be calling. So you'll notice this is in the beginning part of the sketch. This is not in the setup. This is not in the loop. This is a function that has been written, and then within the loop we will simply call the function. So with this, if you take a look at it, again, there's just a whole bunch of stuff here that you probably don't want to mess with. The one thing that you might want to mess with, maybe, is this particular area, and this is where I put the ETCG note. I did not modify this. To be clear, I did a lot of modifications of this. I modified this about 500 different ways, and then I put it back to how it was. It was like, you know what? After a day of messing with this, we're just going to leave this how it is and move on to the next project. This right here is how you actually create the name for the AVI file. So digital write, SDCS high. And then what we're doing here is we're basically creating a random name. So we create a random seed using an analog read. So this is a function in order to create, basically be able to create a random number. Then we're saying the variable n is going to equal random between 2 and 999. Then what we're going to be doing is we're going to be turning that n into this itoa function. This actually turns a string into so it turns an int, it turns a number into a string, and so we're going to feed it the n. We're going to then call it str. The output of this is going to be str, and this is base 10. So basically just 1, 2, 3, 4, 5, 6, saying what kind of numbering system it is. So basically what we're doing here is we're turning the value that comes from random, that's n, we're feeding it in. We're now going to call it str. It's going to be a string, and it's under the base 10 format, so they know what that is. Then we're going to string cat. So basically this is concatenate. So we then concatenate on the string that we just created, the .avi. So we're going to create a random number between 2 and 999. We're going to turn that number into a string. That string we are then going to add .avi at the end, and then that is going to be the name of our file, 2.avi, 877.avi. So on and so forth, you get the point. Then the out file, this is the file that's actually going to be created, going to be written to the SD card, sd.open, so str, what we've created up here, overwrite, create, truncate, the whole 9 yards. And so basically this is what is going to be creating the name for the file and then writing it to the SD card. You can modify this. You can modify this a lot of different ways. And a lot of different ways, frankly, don't work. This way, I will say, works. So try it this way, and then if you want to try to modify the file names that the files are saved as, then you can go in and mess with it. Past that, we're going to go down here. We're going to see a whole bunch of, again, different things for that are required to actually be able to save the AVI file. We go down, we go down, we go down, we go down. We can see it's a pretty large, long function that they've created here. This is all still that function that was created. Whole bunch of stuff that you basically don't want to mess with. Then down here, we're going to be serial printing out. So we're going to be serial printing out some results once a video has been captured. And then here we get to the setup. So void setup. In the void setup, under the ETCG note, we do have to turn that PIR pin to input. So pin mode, PIR pin, input, so that we can actually get an input from the PIR sensor. And again, here, there's a lot more stuff that basically we are not going to mess with. We're going to keep scrolling down, lots of whiles, lots of ifs, lots of elses. Keep going down until we can find a loop. Then all the way down here is our loop. And look at how small that loop is. It's a tiny little loop. Tiny, 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 tiny little loop because everything else has been written in the functions up above. So what we're going to do here is basically we're going to do the PIR reading equals a digital read of the PIR pin. Right? So it's going to be detecting whatever the PIR sensor is detecting. If the PIR reading equals high, so if that reading, it's detecting motion, then what we're going to do is simply do serial.println motion detected, and then we're going to call that video to SD function that we scrolled through up above. And that's literally all we have to do. I'm simply going to delay this for 1 second here. In the original version of this code, for whatever reason, it delays for 30 seconds. So again, do be careful with things like delays when you're using examples, because they can use really long delays for whatever reason. I'm simply delaying it for a second until it goes to try to read a motion again. Else, basically, if motion is not detected, all I'm simply doing is, as it loops through, we're doing a serial.println, no motion detected. So we'll see no motion detected, and we'll keep seeing that, zooming across the screen. And then basically, as soon as motion is detected, it will say motion is detected, and it will basically take the video, and we'll get some information out of it. So with that, what I'm going to do is I'm actually going to slot the SD card into our little contraption here. I'm then going to plug the Arduino into the computer, and then we are going to upload the code. So now that's plugged in. I'm simply going to upload the code. Everything should be fine here. Always cross your fingers. Should be fine. Should not be any major issues here. Again, doing the basic uploading process. Okay, so we now see it's done uploading. We will go to Tools, we'll go to Serial Monitor, and we'll see what it has to tell us. Okay, so the ArduCam has started, so that tells us that the ArduCam has started. Do you remember with this to set the baud to 1,100, 5,200, and basically I put a little timestamp over here. So do make sure that you've done this. Now, it is not detecting any motion right now because I'm trying to keep my mouth pretty still, so I'm going to move. I move. It then says motion detected. We now see it is recording for those 200 frames. So remember where I showed you that configuration for how many frames it's recording. That's where it's set there. And again, for this, it takes about 15 seconds or so. I'm going to uncheck the auto scroll. So again, one thing is with this, remember, as soon as it's done, it'll go back to scrolling through and saying no motion detected. So if you want to go back and take a look at what got printed out, it can be a bit of an issue if you have the auto scroll on. So I'm simply turning the auto scroll off right here just to make life a little bit easier so I can read the output. And so, I don't know, did I say 15 seconds? Maybe 20 seconds. I don't know, however long it takes to do 200 frames. It's one of those things. You're dealing with a microcontroller here. You're dealing with a microcontroller. It'll give you what it wants to give you. Okay, there we go. So so it actually spit out. So we can see video recorded and saved. Recorded 39 seconds. Okay, so it took 39 seconds, 200 frames. Tells you what the file size is. Tells you what the FPS is. Tells you what the max data rate is. Frame duration, average frame length, so on and so forth. And then it just goes back doing that whole motion detected. It detected another motion again, and so now it is recording and asking you to wait. Again, that spits out, and since I have the auto scroll on, it just goes blazing past. So that's basically how this project works. So from here, all I need to do is then pull out the SD card, plug it into my computer, and view what the AVI files are. So I'm just going to rip it out. Just unplug it, dangerously unplug it the way I do. We're now going to go over to my little lab computer. I'm going to plug the SD card into the lab computer. Going to open this up, wait for the thing to come up, and now we can see we have 3 AVI files. So again, we're simply random naming here, so 952, 472, 43. Now this is an AVI file, so I usually use AVI files on Windows computers. You will find with the ArduCam, the ArduCam is very biased towards the Windows world. The little host viewer app to actually be able to view out of the webcam only works on Windows. things like AVI is built for Windows, whole 9 yards. So if you have a Windows computer, you should be able to just double click on this AVI file and it should work. Since I have a Mac, what I can do is I just simply downloaded the VLC player. I can grab this 952. Let me just do this. All right, so I can grab this 952 AVI, I can just shove it into the VLC player, I can double click. It's gonna tell me there's an error. I'll just do play as is. And there you go, look at me. That is my little motion detected video player right there. I can stop that. I can put in the 472. And basically, again, double click on this. Again, for whatever reason, you always get this error. And now, again, you're now getting a very, very, very choppy video file of me. So this is all simply detected. This is basically triggered off of that PIR motion sensor. As you can see, it's about a 30-second video clip. And so you can use this for nanny cams or security or whatever you want to do. And that's really basically how this project works. So there you go. Now you know how to create your own motion-activated spy video camera. So you got a little PIR sensor here. You got a little ArduCam here. You got your SD card and your data logging shield. And with this, again, basically, you can just have that PIR sensor pointed in a direction, have the video camera pointed in a direction, and when somebody walks by, it will then start taking about a 30-second clip of whatever is going on. I will tell you, I am somebody who absolutely loves Arduino. Do not get me wrong. I love Arduino. I love the concept of a basic microcontroller, and when you're dealing with temperature sensors and humidity sensors and water sensors and a lot of very, very simple things, I think the Arduino is just, as they say, the bee's knees. Once you start getting into the video world, once you start getting into actually needing some resources, things like RAM would be very nice. I do have to say, using an Arduino in order to do like video projects becomes a pain in the butt very, very, very quickly. Things that you think should be very easy to accomplish, like incredibly easy to accomplish, like you're not even thinking it should be a problem, can end up taking you a long time to figure out a solution, or there may not be a solution for it. Again, an Arduino is simply a very basic microcontroller. It is not a full-fledged computer. So a lot of things that you may want to do with a camera, right? You see a camera like this, you think, oh wow, having a camera in an IoT project, that would be great. You probably want to go down the Raspberry Pi route. This works. Don't get me wrong, this works. If you want to add a camera to your Arduino project, you definitely can do it. But it is very, very basic. Very basic. That's really all I have to say. The other thing too, again, as I've been doing more projects, working with the ArduCam more, you really do see that ArduCam is very biased for the Windows world. You'll notice when I am coding for the ArduCam, I'm actually using a Windows computer, not my standard Mac computer, and things for like with the AVI file, things like the little host app that allows you to view out of the ArduCam. There's a lot of things that just by default are built for the Windows world. So if you are going to be messing around with the ArduCam, I'd highly recommend you get a Windows computer to do it. You'll have a lot less problems. It'll be a lot easier to troubleshoot what is going on if you do that. Other than that, again, this is a pretty simple project. We're just adding on that little PIR sensor, having that trigger that video to SD function, and away you go. If you want to go in there and you want to modify how the video file is named, you can go in there and do that. I will tell you, it works. You can come up with other names, other ways to name your video file. But even ArduCam recommends that the name is very small. Again, that like three or four characters before the period AVI. And again, one of the things that I noticed is sometimes I get it to work great. Like there's certain versions that worked wonderfully. Other things, just a small, tiny tweak, wouldn't think would be any issue, and the code would completely fail. So that is just something to keep in mind if you do go in there and try to modify how the video files are named. There are ways to do it. To be clear, 100% clear, you can modify how the video files are named, but you know. Results may vary. Results may vary. So think about this more as a learning project, I would probably say, than anything else. Again, one of the things you want to be thinking about with anything that you put into a production environment is not only that it technically works, but you also have some kind of user interface, user experience that isn't horrible. Again, with this, without being able to write a log file, with having to name the video files basically with random names, with some of those types of things, the user experience for this would be pretty poor. Imagine if you put this camera into a real world environment, it takes 200 or 300 clips. And again, that part, it technically works fine. You get the AVI file, the AVI files play, the whole 9 yards. But one of the issues you may run into is, oh, okay, I need to know what happened at 3 o'clock. And you have 200 video clips with completely random names. You find the video file that was filmed at 3 o'clock. Was it this one? No. 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 The real world about technology. It's not simply about creating something that functionally works. It's also something that's not going to drive your users out of their bloody minds. So anyways, I think this is a pretty cool project. Again, a pretty cool basic learning project. As always, I enjoy doing this video, and I look forward to seeing you at the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.